Hello everyone. Nowadays coding is not only about writing our own code but also consuming existing popular and robust APIs handling a wide variety of applications. In this video, we'll walk through a weather app built using Python which fetches real-time weather data from the internet using an external API. Before we begin, there is one important prerequisite. To use this application, you need to register on the website OpenWeatherMap.org and generate a free API key. Once you sign up, you'll get an API key which allows your Python program to communicate with the OpenWeatherMap servers and fetch live weather data. In this project, we'll use that API key to get temperature, weather description, humidity, and wind speed for one or multiple cities. Let's understand what this weather app can do. This is a menu-driven application that gives the user three options: check weather for a single city, check weather for multiple cities, exit the application. The app uses the requests library to call the OpenWeatherMap API and displays the data in a clean, readable format. Let's have a look at the app in action. We start by importing the requests module. This library allows Python to send HTTP requests to web APIs and receive responses, which is essential when working with online services. Then we define two important variables, API key and base URL. API key stores the unique key you receive after registering on OpenWeatherMap, and base URL is the endpoint we will call to fetch weather data for a city. We can have a look at the base URL. It is given as https API openweathermap.org data 2.5 /weather. The entire application runs inside an infinite loop. This allows the user to perform multiple weather checks without restarting the program. While printing the main menu for the weather app, we display the options for the user to take their choice as input. Option 1 is for single city weather. Option 2 is for multiple city weather. And option 3 is for exiting the app. In case of a single city weather, when the user makes a menu choice option of 1, the program asks for a city name and fetches weather data for that city. The query parameters Q, app ID and units are set as city, API key and metric in JSON format in variable named params. The units equal to metric parameter ensures that temperature is returned in Celsius. API request is made to the weather API using request.get and the data returned is stored in a variable named response. If response status code equals 200 means the city is found, we extract the JSON data and display temperature, weather description, humidity and wind speed. This data is stored in a dictionary for structured access. If the city name is invalid or not found, the program displays an error message and again prompts the user for a city name. If menu choice equal to 2, we get the multiple city weather option. This multiple city weather option allows the user to check weather for multiple cities in one run. First, the user is asked how many cities they want to check, between 1 and 4. The number of cities input is validated for being a proper number between 1 and 4, and the while true loop breaks when a valid entry is given. There is a for loop for accepting data for all the cities within a dictionary of dictionaries named weather, which carries detail for each city as a separate entry. The city names are stored in a set named cities to avoid duplication. Within the for loop, we have a while true loop which keeps on prompting for the city name until it's valid as signaled by success response status of 200. In case of a success, the data for the city is stored in the weather dictionary with city name as the key. Once all cities are processed, the app displays a tabular summary with each row showing city name, temperature, weather description, humidity and wind speed. This makes it very easy to compare weather conditions across multiple cities. If user enters 3 as the choice, the program exits with a goodbye message. In case the user enters a choice which does not fall under 1 to 3, the program displays an error and returns to the main menu. This weather app is a great example of how Python can interact with real-world web services. Through this project, you learned how to use APIs, how to send HTTP requests using Python, how to parse JSON data, how to build menu-driven applications, and how to validate user input. Try extending this project by adding features like forecasts, icons, or saving data to a file. Thanks for watching.